Hey Ramblers, welcome to Spirit Week. In this video, we're going to learn how to identify the medians of a triangle and the altitudes of a triangle, and we're going to learn why in some proofs we use something called an auxiliary line, although I'm going to offer a huge caution not to use auxiliary lines very often. Finally, we're going to notice that we're moving into proofs that are more complex than they were only a week ago. We're going to start doing steps beyond CPCTC. So in other words, we'll prove a triangle congruent, prove some parts congruent using CPCTC, and then we're going to start proving other things in the triangle congruent. So it starts to get more complex. Please make sure you're keeping up with all your flashcards. If you have any trouble, come on and see me during a free period or before and after school. Okay, I hope this video helps, and go Ramblers. The first thing we want to do is take a look at what the definition of a median and of an altitude is. A median is a segment drawn from a vertex to the midpoint of the opposite side. Sounds easy enough, but students often have trouble with confusing medians with altitudes. So let's take a look at a few of what the medians would look like. The median 2BC would come from vertex A and would meet at D, the midpoint of BC. If I were to draw the median to AC, what vertex would that come from? Well, the median to AC would have to come from vertex B, and it would meet at F, which would be the midpoint of this side. Finally, the last median would be drawn to the midpoint of AB. So those would be your three medians. And as you can see, they all meet at a single point, which is the center of gravity of the triangle. In other words, if you were to balance the triangle on the tip of a pencil, this point where the medians met would be where you'd have to have the triangle balanced. It's called the centroid, and while we won't get into it much in this class, it's interesting to know. Let's then take a look at altitudes. An altitude is a segment drawn from a vertex perpendicular to the opposite side. Well, that's easy enough when we draw the segment from C to AB because it's inside the triangle. But what happens when we try to draw a line perpendicular to BC? Well, BC isn't going to meet a line drawn perpendicular from point A. So what we'll have to do is we'll have to extend BC so that when we draw the altitude from A, it will meet it outside the triangle, and that's okay. The same thing we'll have to do if we're drawing the altitude from point B, because in order to draw a line perpendicular to AC, it's going to meet AC outside the triangle. So we would have to extend it to point H. Now, it's interesting to look at, of the three altitudes, two of them were outside the triangle. That's because what we'll learn is an obtuse triangle. If I change the triangle to a right triangle, you'll notice that two of the altitudes become sides. And then as it becomes an acute triangle, all the altitudes are on the inside. So you have to be careful. An obtuse triangle is going to have two of its altitudes outside the triangle. Let's talk then about auxiliary lines. Auxiliary lines are lines which we draw while we're proving something in order to create a new figure in the diagram that we can use in the proof. Now that's not a definition you're going to need to make a flashcard for. That's just something that I want you to understand as we go through this video. So let's take a look at an example, because the definition is really much harder to understand than just seeing it in an example. All right, suppose we're given circle O, and you're told that GJ is congruent to JH. Can you prove that angle G is congruent to angle H? Well, let's take a look at a proof. We're given circle O, and that GJ is congruent to JH. Well, we also know from the last section that GO is going to be congruent to HO because all radii of a circle are congruent. Now we're going to draw JO, and the reason is one of Euclid's axioms, that 2 points determine a line. When we draw JO, we've now created 2 triangles, and we can show that JO is congruent to JO by the reflexive property. That means that triangle JOG is congruent to JOH by side, 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 which means angle J is congruent to angle H by CPCTC. So you see how we drew the auxiliary line JO in order to create 2 triangles which we could prove congruent, and then we could get the angles congruent by CPCTC. That's a good example of when to use an auxiliary line. But I also want to point out to you, I hope you could see from the diagram that an auxiliary line just kind of was obvious to draw. Be very careful with auxiliary lines. I've seen a lot of students go completely in the wrong direction, drawing auxiliary lines and proving things that were completely incorrect. In general, auxiliary lines are very uncommon to use, and it's usually quite obvious when you should create one. It usually is at a time when you have to create a triangle because they don't exist in the diagram already. Okay, so that's a look at medians, altitudes, and auxiliary lines. I hope you can keep the two straight, especially medians and altitudes. And auxiliary lines, please be really sparing when you use them. They don't come up very often, and in fact the diagrams that we'll see in the books really kind of they hint pretty well that you need to draw an auxiliary line. So be very careful with it. I hope you also agree that the proofs are, while they're getting a little longer, they're also getting a little more interesting. So I hope that you're going to enjoy the homework a little bit more than you may have in Chapter 2. Okay, I hope this video helped, and once again, go Ramblers!